Welcome back to Pre-Algebra with Miss Betsy. Today we're going to begin to learn how to solve inequalities, and we're going to see that while the approach that you use is very similar to that which you use when you're solving an equation, there's a little bit of a twist here that you have to be on guard for. If you're using the same text that I am, which is Pre-Algebra for Christian Schools, published by Bob Jones University Press, first edition, you'll find that we're in section 8.7 of our text. It's page 268, Solving Inequalities. Before we get started though, can you tell me how much it costs pirates to get earrings? Well, it costs them about $1 an ear. That one is pretty good for a lame one. It's $1 an ear to get a pirate his earring. So let's go ahead and see what we have in section 8.7. We know what an equation is. An equation has an equal sign. Well, what is an inequality? An inequality is something that looks like an equation, but it includes, rather than just an equal sign, it's going to have a greater than or a less than symbol. And it may include the equal symbol as well, greater than, less than. If we put the equal sign underneath it, then this would be greater than or equal to less than or equal to. So we have greater than or equal to, less than or equal to. And a mathematical statement that is connected with greater than, less than, greater than or equal to, less than or equal to, these are called inequalities, and you can also solve those when you include variables in a very similar fashion to how you solve equations. So let's just look at something. What if we have 4 is less than 9? Is that a true statement? Well, what if we say 4 plus 2 is less than 9 plus 2? Is that true? That 4 plus 2 is less than 9 plus 2? Well, let's see. Yes. 6 is less than 11. So you see, if you start off with a number being less than another, you can add the same quantity to both sides of the equation, and you still have a true statement, don't you? What happens here? And you see, the whole way down here we have less than. When you perform your operation of addition, the inequality is in the same direction. 4 is less than 9. 6 is less than 11. The order, if you will, of that inequality symbol is still the same. The smaller number is on the left. You add the same quantity to both sides. The smaller number here is still on the left. Well, let's see what happens if we subtract. If we start off with, it's true that 4 is less than 9, what happens if we subtract 3 from both sides of the equation? Do we still end up with a statement that's true? 4 is less than 9, subtract 3, it's still true that 1 is less than 6, and the order of this inequality is still the same. The smaller number is on the left where it belongs. So what we've illustrated here is that when you add or subtract the same number to both sides of an inequality, the direction of the inequality symbol doesn't change, and that's what they call the addition and subtraction property of inequality. And so it's something that's always true. Now let's see what happens with multiplication and addition. Do I need multiplication and addition? I mean multiplication and division. what happens if we start off with 8 is greater than 2? True? Let's see what happens if we multiply by 2. Is that still true? 16 is greater than 4. So that works, doesn't it? Well, what if we have 8 is greater than 2, and we divide both sides of this equation by 2? Is that still going to be true? Yes. 4 is greater than 1. I forgot to put the 1 there. 4 is greater than 1. The direction of this inequality symbol didn't change. Now let's see what happens, however, with a positive and a negative number that's being involved in here. Start off with our same, 8 is greater than 2. What happens if we multiply 8 times a negative 2 instead of multiplying by a positive 2? What are we going to end up with? Well, 8 times a negative 2 is a negative 16. 2 times a negative 2 is a negative 4. Which of these is the larger number? Is negative 16 larger, or is negative 4 smaller? Or is negative 4 larger? Well, negative 16 is smaller than negative 4. Look what happened. We started off with greater than. We multiplied by a negative number. We ended up with less than. This is what we say that the direction of the inequality changes. Let's see what happens if we're going to divide now. We start off knowing that 8 is greater than 2. Now we're going to divide by a negative 2 and see what happens. 8 divided by a negative 2 is a... No, okay, what did I do wrong? That should be a 2. 8 divided by a negative 2 is negative 4. 2 divided by a negative 2 is a negative 1. Which is the larger number? Is negative 4 greater than negative 1? Or is negative 1 greater than negative 4? Yeah, negative 4 is a smaller number. And look, the direction of that inequality symbol changed. So remember, when you're multiplying positive numbers together, you get a positive answer. But when you, and likewise with division, but when you multiply or divide by a negative number, sometimes you don't have the same sign. Like if you have a positive multiplied by a negative, your number becomes negative. So what happens in actuality when you are multiplying and dividing inequalities by a negative number, the direction of the inequality symbol changes. Makes no difference with subtracting or adding negative numbers. It's only when you multiply or divide, and it's only when you multiply or divide by a negative number. Let me show you, go back to this addition and subtraction. Now you can't prove something by just pulling a few examples out of your hat, but we're illustrating properties that have been shown to be true. So if we have 8 is greater than 2, what happens if we subtract a negative number? 8 minus a negative 2. Is that still greater than 2 minus a negative 2? We subtract a negative, it's the same as adding a positive. So we see that subtracting a negative number has no effect on the direction of the inequality. Well, what if we want to add a negative number plus a negative 2? Let me get my eraser here as I smear my board. If I start with 8 is greater than 2, I want to add a negative number greater than 2 plus a negative 2. 6 is still greater than 0. because this has to do with subtraction is the same as adding the opposite. So addition and subtraction doesn't matter if you're dealing with negative numbers, has no effect whatsoever. It's when you multiply or divide, and only when you multiply or divide by a negative number. So write this in your notes and learn it. When multiplying or dividing inequalities only, inequalities by a negative number, you're going to need to reverse the direction of the inequality symbol. You must change the direction of that inequality symbol. Reverse direction of the inequality symbol. And I need to not drop an M out of my word, out of my spelling. Took a good while writing this down on the board. You got to see the back the whole time. I hate having my back to the camera. This should tell you that this is very, very important. When multiplying or dividing an inequality by a negative number, you have to change the direction of that inequality symbol. Because you do. Because it changes the order of which number is smaller and which number is greater. It's only when you're multiplying or dividing. It's only when you're multiplying inequalities. And it's only by a negative number. It doesn't matter if you add or subtract a negative number. It's when you multiply or divide by a negative number. Okay? Let's go ahead and solve a couple of these inequalities. And you'll see that you solve them just exactly like you solve equations, except when you multiply or divide by a negative number. For example, right here, x minus 4 is less than a negative 9. We want to isolate that variable. What has been done to the x? We've subtracted 4. The inverse of subtraction is addition. So we are going to add a 4 to both sides of our inequality, and we see that for our solution we have x is less than a negative 5. You say, oh, but we've got a negative 9. Has nothing to do with anything. We've subtracted a 4. Doesn't affect anything. The direction of the inequality symbol changes only when you multiply or divide by a negative number. What exactly does x less than 5 mean? Well, how would you graph that on a number line? You would have an open circle at your negative 5, and any number to the left of negative 5 on the number line would work. So is this true? Well, let's see. Let's pick negative 100. Test. Negative 100 minus 4. Is that less than a negative 9? Negative 104 is smaller than negative 9. Well, why couldn't it just be negative 5? Let's test that. Negative 5 minus 9, is that less than a negative 9? Well, you have a negative 9 on both sides of our symbol, but the difference is we don't have an equal. Is negative 9 less than negative 9? No, it's the same. Now what if we had negative 9 is less than or equal? Then it would be okay. We do one more illustration. What if our graph says everything going this direction? What about something to the right? What about 0? Is 0 minus 4 less than a negative 9? No, negative 4 is not less than negative 9, it's greater. So this is what you're going to do to solve an inequality. You're going to solve it just as if you were solving an equation. Let me do one more for you, and this one will be one where the direction of the inequality symbol does reverse. Negative 4x plus 3 greater than 23. What's happened to the variable? First it's been multiplied by a negative 4, and then 3 has been added to it. Excuse me a moment. To undo the operations that have been performed on the x, we undo them in reverse order. First it multiplied by 4, then 3 was added to the product. Now we're going to subtract 3 from both sides of that inequality. Negative 4x plus 3 minus 3 greater than 23 minus 3. So we end up with negative 4x is greater than 20. Now what's happened here? This has been multiplied by a negative 4. So what are we going to do to undo that? What's the inverse of multiplying by negative 4? It is to divide by a negative 4. We are dividing by a negative number, so what do we have to do? Reverse the inequality symbol. Or reverse the order. This right here is huge. We're dividing by a negative number, so the direction of your inequality symbol has to change. X is less than a negative 5. Any number less than a negative 5 is going to make this a true statement. For example, negative 6. Negative 6 times a negative 4 is positive 24. Plus 3 is 27. 27 is greater than 23. Go ahead and work through these. They should be pretty straightforward. The only thing you need to remember is multiply or divide an inequality by a negative number, and the direction of that inequality symbol must reverse. Enjoy your work. I will see you next time.